What if I told you that some rocks on Earth came from Mars? Others may have come from the cores of ancient asteroids, and some contain tiny grains that existed before the sun was born. These aren't science fiction objects, they're meteorites. And today, we're breaking down the major types, from ordinary space rocks to some of the strangest objects ever found on Earth.
First, 3 words. A meteoroid is a rock traveling through space. When it enters Earth's atmosphere and creates a streak of light, it's a meteor. If it survives and reaches the ground, it's a meteorite. Now, let's look at what's inside them.
First, stony meteorites. They're mostly made of silicate minerals and are the most common meteorites found on Earth. They come in 2 major groups, chondrites and achondrites. Chondrites are some of the most primitive material in the solar system. Many contain tiny spherical structures called chondrules, which formed more than 4.5 billion years ago. They're basically pieces of the solar system's original building material. Achondrites are different. Their parent bodies experienced enough heat to melt and separate their materials, destroying those original chondrules. Some came from asteroids. Others came from the Moon or Mars. Yes, scientists have actual pieces of Mars in laboratories on Earth.
Chondrites come in several groups. Ordinary chondrites are the most common meteorites recovered on Earth. Then there are carbonaceous chondrites. These can contain carbon-rich compounds, water-bearing minerals, and organic molecules. They're especially valuable because they preserve clues about the chemistry of the early solar system. Other groups, such as enstatite chondrites, have different chemical compositions that reveal different origins and environments. So even though they all look like rocks, their chemistry can tell completely different stories.
Now, forget rocks. Meet the iron meteorites. They're mostly iron and nickel and are much denser than ordinary stony meteorites. Many are thought to come from the metallic cores of differentiated asteroids. And some have an incredible feature. Cut one open, polish it, and etch its surface, and you can reveal a geometric pattern called the Widmanstätten pattern. It formed as the metal cooled extremely slowly inside its parent asteroid. We're talking millions of years. So that strange pattern is basically an ancient record of an asteroid's cooling process.
Then there's the rare combination, stony-iron meteorites. They're made of roughly equal parts rock and metal. 2 important groups are pallasites and mesosiderites. Pallasites contain greenish olivine crystals surrounded by iron-nickel metal. When sliced and polished, they can look almost like cosmic stained glass. Mesosiderites are mixtures of rocky and metallic material that were violently mixed during collisions involving their parent bodies. They're basically evidence of an asteroid's extremely chaotic past.
But some meteorites contain something even older, presolar grains. These microscopic grains formed around ancient stars before the solar system existed. They survived the formation of the sun, planets, asteroids, and eventually ended up inside meteorites. That means a tiny grain in a meteorite can be older than the solar system itself. It's like finding a photograph from before your entire neighborhood existed. So the next time you see a boring-looking rock, remember, it could be from an asteroid, the Moon, Mars, or even a star that died before our solar system existed. Not bad for a pebble.